ATA offers ultra-effective prototyping and test software solutions to the aerospace industry. Our principal engineers began their careers working with some of the industry's earliest space simulators. They played a part in helping to define the industry's use of simulation for prototyping and test. Today, ATA is an innovator in designing and delivering prototype and test software solutions that meets the needs of today's fast-paced and cash-strapped projects. According to eLateral, prototyping is a strategy in system development in which a scaled-down system or portions of a system is constructed in a short time, tested, and improved in several iterations. A prototype is an initial version of a system that is quickly developed to test the effectiveness of the overall design being used to solve a particular problem. Prototyping is similar to the evolutionary or iterative design process. It is sometimes termed rapid prototyping and is similar to rapid application development. There is great uncertainty as to whether a new design will actually meet program requirements. A prototype is usually used as part of a design process to allow engineers and designers the ability to explore design alternatives, test theories, and confirm performance prior to starting production of a new product. Through the years, ATA has accumulated an extensive software tool library and refined it with this process in mind. Because ATA consistently develops its software with an eye toward modularity and reuse, this library greatly reduces the time and cost of prototyping. When customers work with ATA, they leverage that vast library of code to shorten their own development time. Since prototyping is the initial step in a development process, it is important to consider the implications for later integration phases when developing methods for prototyping. ATA's prototyping and test process is not hardware or software specific, and we have experience working with a number of platforms. Our process follows a flexible, yet disciplined approach, as outlined on the following slides. One of the solutions ATA has developed is an adaptable prototyping and test system that leverages features of National Instruments test platforms to create efficiencies in the development process. One of our oft-used solutions utilizes LabVIEW, the ATA Aerospace Toolkit, and the PXI, an open, PC-based platform with easily reconfigurable I/O. This system has been proven highly effective in the prototyping and test of control software. Throughout the years, we have continually refined our tools and processes to emphasize modularity and reuse. This chart illustrates ATA's design methodology. Requirements are carefully derived from operating characteristics and data. A prototype is then constructed using a language appropriate for the project. We have experience with the modeling languages predominantly used in aerospace. After an initial prototype is constructed, design analysis can then be performed on the prototype. Simulation provides the ability to test the prototype. The prototyping and analysis processes are iterative, and each iteration should be a step toward a fully integrated, high-fidelity software test system, often referred to as software in the loop, or SIL. This step is fundamental in validating a prototype. Finally, depending on the project objectives, hardware can replace simulation components for integrated hardware and software testing in a hardware in the loop, or HIL test. Our experience with developing numerous prototypes for industry has led to a process that is both cost-effective yet highly successful. Key enablers are the portability of ATA's software tools and the appropriate use of COTS technologies. ATA stands out for its work in software system prototyping and test for flight vehicles. These software systems include flight software and high-fidelity vehicle simulations. Our experience is somewhat unique in this field because several of the company's principals have certified systems for NASA's manned vehicles. The first software project ATA undertook was a 6 degree of freedom upper stage deployed from shuttle. We developed a software prototype system and then flew the model in a real-time environment in the laboratory. This effort was so successful that our customer was awarded the lead for developing upper stages. Next, ATA helped a customer develop software and hardware for the GNNC of the ATED vehicle. ATA prototyped the system in its lab and flew the system in a real-time environment. The rocket flew successfully with the verified GNNC software on board. The customer declared the flight a 100% success. ATA has constructed numerous other prototypes, including those listed here. For a detailed discussion of ATA's prototyping program history, please select the Contact ATA option at the end of this CD. As an example, ATA recently constructed a thrust vector-controlled prototype system for a small two-stage rocket. The purpose of this system was to give ATA the ability to demonstrate its own commercially available flight dynamics software toolkit. This particular example demonstrates critical aspects of that toolkit. To solve this problem, we used our standard prototyping process. This mission had the rocket launch from a rail and points it in the direction of the target. The first of the two stages burns for 6.2 seconds. Note the wobble due to uncontrolled flight. Then there is a separation and immediate second stage ignition. The second stage burn lasts a little over 29 seconds. The TVC is only active during the second stage boost. The GNNC uses it to maintain attitude during the second stage. Note the relative stability during second stage flight. The rocket is capable of extremely fast acceleration, reaching Mach 8 before second stage burnout. ATA chose LabVIEW to code both the GNNC and the vehicle simulation. The control system and simulation were prototyped, a SIL was constructed, and a real-time hardware-in-the-loop test was performed.